All right, so this is the first of two lessons from section 4.1 of the textbook, looking at multiplying polynomials. And in practice, we'll end up multiplying and then also adding and subtracting, which is collecting like terms. Really just builds on quite nicely what was reviewed. But again, if you haven't seen the review video that comes before this, which is lesson 4.0, definitely look at that first, because I'm going to assume you've seen those and developed some sort of sense of confidence with those ideas. That's it. For each of these, I want to expand and simplify, which means I want to multiply and then collect like terms. And when I say multiply, right here I have x plus 1 times x plus 2. So I'm multiplying two binomials, we call them. Right? This is a binomial, has two terms. This is a binomial. I don't really care too much about the terms, the vocabulary, more just that we understand the ideas. And so when I multiply this out, essentially it means everything inside here times everything inside here. And there's two terms in each. So there's going to be a total of 4 multiplication steps, 2 times 2. And they are literally like this: x times x, x times 2, 1 times x, and 1 times 2. I can do those in any order. I just don't want to lose track. And so I'm always going to recommend you draw these little arcs like I drew, just to keep track of what you've done and what's left. So I'll go back to the start, though. All right, so first step, x times x, which is x squared. X times 2, which is 2x. Now that said, if I just leave it like this, this actually means x squared times 2x. I want it to mean plus, because again, all these terms are being added to each other. And so that plus sign is really important. Next, 1 times x is positive 1x. And the last multiplication step, 1 times 2, is positive 2. So that's the expand part that it says up here. Now there's a simplify part, which is see if I can collect some like terms. And usually there are. In this case, there's 2 like terms right there. 2x plus 1x is 3x. So I can write these terms in any order, but usually we put the biggest power first, and then next, and then the constant last. Quite often we call this foiling, which stands for first outside, inside, last. But FOIL is not really a mathematical term. It's honestly, it's just what we're doing is distributing the x and distributing the 1 in this case. We're just multiplying everything out. All right, that's it. Same idea here. So first, x times x. It's x squared. X times 2, which is 2x. Now we've got a negative here. Always got to be a little more careful. Negative 1 times x is negative x, or I could say negative 1x. And negative 1 times 2 is negative 2. Again, look for like terms. Usually, but not always, there are. Here again, we have these like terms. 2x take away x is 1x. And that's it. Again, it's never wrong to put a coefficient of 1 in front of these. You just don't have to, so hence I'm not usually doing that. Now this one we got to be careful about. A common mistake is to think this equals, a common mistake is to do something like this. And imagine each of these being raised to a power of 2. That makes sense when you have factors. Again, factors means parts, numbers, or values that are being multiplied to each other all to a power. For example, if I had x times y all to the power of 2, then yes, x and y are factors. It's x times y. But I'm not multiplying here, I'm subtracting. And so if you make that mistake, well, it's a common mistake, and I highly recommend you write it down. If you make that mistake, you think the answer is like x squared minus 1 squared, or x squared plus 1 squared, something like that. They're both wrong, so they're very common mistakes, though. And so, how can I prove this is wrong? Well, think about what x minus 1 squared means. It means x minus 1 times x minus 1. Right? We know what an exponent means. And so if you actually write down what this means, we see, OK, there's going to be 1, 2, 3, 4 multiplication steps. And so first I have x times x, which is x squared. Then I have x times negative 1, which is negative 1x. Then I do that again. Negative 1 times x is negative 1x. And then for my last step is negative 1 times negative 1, which is positive 1. And so notice when I collect like terms, those two I've highlighted do not cancel each other out. Negative 1 take away another 1 is negative 2. And so my final answer is actually x squared minus 2x plus 1. And so I highly recommend you take note of these common mistakes right here. You will almost certainly make them at some point. You may make them a lot, hopefully not, but because then it's kind of it's not a bad thing to make a mistake. It's just kind of frustrating if we keep making the same mistake. And one way to avoid it is to be really clear to ourselves about what these common mistakes are. And that's what I've labeled there. All right, so with that said, let's just look at a slightly different variety, but same idea here. So I have 3 examples. Look at them one at a time. This time, the only difference is everything's a variable. Okay, so I have x times x, x squared, x times y, which is, they're positive, positive xy or yx. Here I have y times x. So I could put y times x, but I'm going to change that in a moment, but I'll put that for now. And then y times y is y squared. Everything's positive. Now the only reason I'm going to change one of these terms is because it may not be obvious right now that these two are like terms. xy and yx are like terms. They're both just an x and a y times each other and nothing else. So that's easy to miss. And so I'm always going to recommend when you're multiplying variables to be consistent and put your variables in alphabetical order. It's for your sake, so you don't miss the fact that these two are like terms. And so if I just go back in time a bit to this step where I went y times x, I'm going to write down instead of y times x, I'm going to write x times y. It's the same thing. And like I said, it just makes it more obvious that these two are like terms. So I have x plus y plus another x plus y. That is 2x y. I think I said x plus y. I should have said xy plus xy is 2xy. And then the other two terms written out. So again, like I said, you don't have to write variables in any particular order. But if you are always writing them in a different order, you may miss the fact that sometimes there's like terms there. All right, same expression here, but now one's plus, one's minus. So x times x, x squared. X times minus y is minus xy. Y times x is yx, but I'm going to write in order of xy, and they're positive. And finally, y times negative y is negative y squared. This time, these two are like terms, but they cancel each other out. I have minus 1xy plus 1xy. Well, minus 1 plus 1 is 0. So in the end, those terms are just gone. So all I have left is x squared minus y squared. I have just two terms. And we'll see this sort of expression a lot throughout this chapter. And lastly, just a combination of variables and coefficients. 2x times x, 2x squared. 2x times minus 3y. So 2 times minus 3 is minus 6. X times y is xy. Negative y times x is a negative. I'm going to put xy in that order. And then lastly, negative y times negative 3y. A negative times a negative is a positive. So positive 3y squared. And again, I have these like terms. And again, it may be helpful to put a 1 right there. And I have negative 6 take away 1. Negative 6 take away 1 is negative 7. And there's no other like terms. Notice in this case, every question that I've worked out has had one pair exactly of like terms. That is quite common. Like I said, it's not always going to happen, but it is quite common. All right, so I have one more sort of algebraic example and then a more sort of visual example, and that's done. Again, lessons like this don't require a ton of notes. They need some examples. What you really need is just some practice. And not a ton of practice, but definitely some practice. OK, so here I just have the most complicated algebraic work for this lesson. And so here what I have is two terms, x plus 2 times 3 terms. So there's going to be a total of 6 multiplication steps here. So it's extra important to be methodical, systematic, like just be clear about what we've done and what's left. So I'm going to go first x times 2x squared, which is 2x cubed. Then I'm going to go x times minus 5x. Well, it's going to be minus 5x squared. And finally, I have x times 1, which is 1x, but positive 1x. OK, that's half my work. Now I have to do these two. I haven't done these and the next couple after that. So positive 2 times 2x squared is 4x squared. Positive 2 times minus 5x is negative 10x. And positive 2 times 1 is positive 2. All right, notice I had 6 steps. These 3 here came from multiplying with the x in the first binomial. These 3 here came from multiplying by the plus 2. I can do these in any order again, I just don't want to miss one. Now I'm looking for like terms. If I look at the 2x cubed, there are no like terms with that. So I'll write that down. If I look at the x squareds, I have an x squared here and an x squared here. So minus 5x squared plus 4x squared is minus 1x squared, or just minus x squared. And then I also have like terms here. Plus 1x minus 10x. Well, plus 1 minus 10 is negative 9. So it's going to be negative 9x. And then that positive 2, that constant at the end, doesn't have a like term. So like I said, these two, this example and the next, are about as complex as it gets for this lesson in terms of algebraic work. And there's a fair amount here. There's lots of little steps, and that's kind of a characteristic of this chapter. There's always going to be lots of little steps. The individual steps are generally quite easy, but it's also the individual steps are quite easy to make a little mistake, especially with exponents or something. Well, that's it. Let's look at this. I have basically 3 factors here. 2 times 3x minus 1 times x plus 2. I'm multiplying 3 factors together, 3 things together. Remember, when you multiply, it doesn't matter what order. For example, if I had 2 times 3 times 5, right? These are 3 factors as well. I could first go 2 times 3 and then multiply that by 5. Or I could go 3 times 5 and then multiply that by 2. Or I had other options as well. I can go 5 times 2 first and then multiply by 3. It all leads to the same thing. So in this case, what I want to multiply first is actually, I want to leave that 2 alone, because that's really the only thing that makes this more tricky than previous questions. So let's ignore the 2 for a bit. Let's multiply these first, because we've seen lots of examples of multiplying like this. So 3x times x is 3x squared. 3x times 2 is 6x. And then down here, minus 1 times x is minus 1x, or minus x. And minus 1 times 2 is negative 2. So just keep in mind all of that I'm highlighting in yellow came from those 2 factors above. So that's it. There's still a 2 in the front of here. OK, which is not a big deal. I just don't want to forget about it. So before I go on, let me actually clean up, because if you notice right here, I have like terms. So I'm going to put those together right now. 3x squared, 6 take away 1 is 5, minus 2. So again, still, everything you see highlighted in yellow is equivalent. Now, I want to multiply by the 2. And I get literally everything you see in yellow doubled times 2. So 6x squared plus 10x minus 4. Now keep in mind, it doesn't matter what order I multiply these. But if I multiplied these 2 together first, let's say I did this first, a common mistake is then they keep multiplying everything out. But again, notice, if I had just 2 times 3 times 5, I have, this goes back to elementary school. And I used to teach elementary school. I never see students do stuff like this. I never see students go 2 times 3 is 6, 2 times 5 is 10, 6 times 10 is 60. Literally, I never see students doing that. I always see students who, usually they just go in order. 2 times 3 is 6, 6 times 5 is 30. But like I said, you can do it in any order. And so keep in mind, same idea here. If I just multiply the 2 to everything, that's not what it's saying here. It's 2. And so just realize you have a choice. And realize, again, if we choose to multiply these together first, it's directly connecting back to everything I've been talking about in this lesson. Only difference is at the end, I want to double everything. OK? With that said, though, the final problem is in your booklet of notes. And it's kind of a visual question. And a lot of our final problems will kind of be like this. So I have a circle inscribed in a square. Now, inscribing a shape inside another is what you see here, for example. A circle inscribed in a square means like this, a circle that fits perfectly inside a square. And the square has a side length of 4x minus 2. And that's what you see from here to here. This side I'm highlighting is 4x minus 2. That's the length of that side. All right. Expand and simplify an expression to represent the area of the circle. So, and it says make sure your answer is exact. So first, how do we find the area of a circle? Well, got to go back to elementary school again. It's pi r squared, where r is the radius. OK, what's the radius of the circle? Well, the radius of the circle is from here to here. Radius is halfway across, or anywhere, straight up and down, whatever. It's all the same thing. In this case, notice the radius must be exactly half of 4x minus 2. I can literally see if I draw the radius up and down compared to what I have drawn for 4x minus 2, it's half that distance. And so the radius of this circle must equal 4x minus 2 cut in half, divided by 2. And we reviewed this sort of stuff in the last lesson. I can just look at each of these terms separately divided by 2. I have 4x over 2 minus 2 over 2, which is 2x minus 1. So there's my radius. The radius of this circle is 2x minus 1. X can be, some variety of numbers. With that said, now let's go to the area. So now, therefore, the area of this circle is going to be pi times 2x minus 1. I'll write that in red, actually. All squared. Now, if you're tempted to change pi to 3.14, please don't, because then it's no longer exact. pi is not exactly, pi is exactly pi. It's approximately 3.14, but it's pi. Just like 2 is approximately 1.99, but it's exactly 2. Right? It's close to 1.99, but it's not. It's 2. And so be exact with pi. Leave it as pi. If you decimalize it, you're not making it exact. And it's honestly more work for no benefit. In this case, what do I do here? Well, remember right here that we looked at something similar to this right at the beginning of this lesson. 2x minus 1 squared means 2x minus 1 times 2x minus 1. And so if I multiply this out, I have 2x times 2x, which is 4x squared. I have 2x times negative 1, which is negative 2x. I have negative 1 times 2x, which is, again, negative 2x. And I have negative 1 times negative 1, which is positive 1. These are like terms right here. Let me put them together. So I have 4x squared minus 4x plus 1. Just don't forget, everything you see here is being multiplied by pi. Right? Plus, everything you see here that's highlighted in yellow is equivalent. 2x minus 1 squared, same as what you see below, and so on. But it's all multiplied by pi. And again, having all this multiplied by pi is very, very, very similar to what having in this question right here, where everything is multiplied by 2. Now, you may like the number 2 more than pi, but they're just numbers. And so in the end, I want to now distribute this pi. I'll do it one step at a time. I'm going to have 3 steps like this, but I'll do it one step at a time. So first, and again, don't go to your calculator. Again, if you do that, you just make things messier for no benefit. So pi times 4x squared is pi times 4x squared. Just that. Now, I can write these factors, pi 4x squared, in any order. By convention, we put the 4 first, then the pi, then the variables. But you don't have to. But I'm going to be boring and be conventional. And so 4 pi x squared. Next, pi times minus 4x. Again, I could say pi is pi times 4x. I mean, that's fine. However, again, I'll be conventional and put the 4 first, then the pi, then the variable. And finally, pi times 1 is pi. And that there is the answer we're looking for. That is the expanded and then simplified expression for the area of the circle. And it's exact, because I'm not decimalizing anything. Keep in mind, if you at all are ever tempted to go to your calculator and decimalize pi, you will get a different looking answer that is not as accurate. It's not terrible, it's just not quite as accurate because you're rounding, and it's just messier and it's more work. So with that said, most of this work is quite algebraic, although you will see this a lot, where at the end we want to connect it to some visuals here. And there's a few useful, it comes back a few times. But most of this is just the mechanics of knowing how to multiply with polynomials. And I'll stop there.